The purpose of this video is to act as an introduction to functions. We're going to talk about the coordinate plane and then how we can graph functions on the coordinate plane as well as create tables that give us input and outputs. So, as you can see down here, I have a crudely drawn coordinate plane. I have my x-axis over here, I have my y-axis going up and down, and right here where they intersect I have what is called the origin, which is the coordinate 0, 0. Now, the purpose of showing us this graph is to get us used to talking about it in terms of quadrants. This is the quadrant that you have more than likely worked with for a good portion of your life. It is where x is positive and y is positive. This is called Quadrant 1, or as I'm going to abbreviate it on the screen, Q1. Quadrant 1 has positive x and positive y. So I'm going to put plus x, comma, plus y. Now, we are used to going around clockwise, meaning we go this way, the same way that a clock goes. But in our coordinate plane, as we are counting the quadrants, we go counterclockwise. So that means from quadrant 1, we move to the left to what is called quadrant 2. And in quadrant 2, our x values are going to the left. So now our x values are negative, but our y values are still going up. So our y values are still positive. So in quadrant 2, we have negative x and positive y values. As we continue going counterclockwise from quadrant 1 to quadrant 2, now we'll head downward into quadrant 3. Let me erase where I've worked the origin. And here we have quadrant 3. And I made a little mistake here with quadrant 2. I wrote the number 2. It's supposed to be a Roman numeral, so quadrant 2 that way. Now we're in quadrant 3. All the way down here, our x values are still going to the left, so our x values are negative, and now our y values are also going down, meaning our y values are negative. So here we have, in quadrant 3, negative x and negative y values. And lastly, as we continue all the way around counterclockwise, going from quadrant 1 to quadrant 2 to quadrant 3, you guessed it, now we are in quadrant 4. So Q with a Roman numeral 4. And here, our x values have turned positive again. They are going to the right. But our y values are still heading down. So our y values are still negative. So in quadrant 4, we say we have positive x values and negative y values. And graphing on a quadrant plane, or coordinate plane, is the same as if we were just graphing in quadrant 1. Figure out your x direction, is it positive or negative? Move that many spaces, and then figure out your y direction, positive or negative, and go in the correct direction. So, we've talked about our coordinate plane. Now, let's talk about functions. What you see before you now is a very basic function. It is read as y equals x plus 2. And it's a relationship between the x value and the y value. The x is known as the input. The y is known as the output. And it makes kind of sense to think of a function in math as a function that you might deal with in the real world, such as using a vending machine. Think about what happens when you use a vending machine. You have some money, You put it into a machine, you push some buttons, telling it what to do with that money, and it outputs your item. It could be a candy bar, or a piece of gum, or chips, or anything like that. So in a real-world setting, vending machines have a function of your inputting money, and they output some sort of food or item that you have chosen based on what is happening when you punch the buttons, or the rule to the function. This function works very similarly. Let's get rid of my little picture here. In a mathematical function, x is your input. So we put something in for x, some sort of value. This is the rule of the function that says, hey, whatever that input is, you're going to add 2 to it. And after that has happened, the function outputs the new value. And that is, in a nutshell, a basic mathematical function. And we can chart our inputs and outputs in an input-output table. Now, I tend to put x and y up at the top. You could write input here and output there. It doesn't make a difference. I like to write x and y because, well, that's the variables we're working with here. But if you want to put input, output, it's up to you. So, if I were to say that x is 0, for my output, I would have, well, the function says 0 plus 2. I put the 0 in for x. I'm going to add 2. And what is my output? My output is just 2. If I put in 1 for x, the rule says whatever I put in for x, I have to add 2. So that's going to give me 1 plus 2, which is 3. And continuing on, if I have, let's just say 2 for x, I put it into the function, which says whatever you have as your x, you have to add 2 to. So I have 2 plus 2, which is 4. And this is your functions. I put in 0, the function spits out 2. I put in 1, the function spits out 3. I put in 2, the function spits out 4. Now, how can I relate this to a graph? Well, a graph is made up of coordinates. The coordinates are generally x values first, comma, y values. So I could make a third column here for coordinates, which I'll just abbreviate COOR, coordinates. And I take my input and the output, and those become our coordinates. So here I would have 0, 2, 1, 3, and 2, 4. And then if I drew my coordinate plane, give me one moment to put that in here, I can graph my coordinates that match this function. So I'll have 0 and 2, so up 2 over none. Then I have 1, 3, so over 1, up 3. And then over again to 2, 4. And if you notice, they kind of look like they're creating a line. That's because what we have worked on right here is actually called a linear equation or a linear function. We'll talk more about those later on, but it's good to get the practice and know exactly what we're doing. So, we have created a function. We've done an input-output table. We've gathered some coordinates based on our inputs and outputs, and we have graphed those coordinates based on the inputs and outputs. That's a lot of stuff. let's try one more real quick just to make sure we have the hang of it. All right, so let's try a new one. All right, our function this time is a little more complicated. It's no longer just x plus 2. This says, hey, whatever your input is, you have to square it, multiply it by 3, and then take away 2. That is how you are going to get your output. So there's a lot more going on this time. But as long as we follow the rules for our input and output, we'll be just fine. So let's start with 0. That one's always a nice one to start with. If I plug 0 in for x, I'm going to have 3 times 0 squared minus 2. And what's that going to give me? 0 squared is 0. 3 times 0 is 0. 0 minus 2 is negative 2. So I get negative 2 as my output. Now if I try an input of 1, I get 3 times 1 squared minus 2. And I follow it all again. 1 squared is 1. 1 times 3 is 3. 3 minus 2 gives me 1. Positive 1 that time. Alright, so I've got a second set of points. And let's just do one more. Let's do 2. So I have 3 times 2 squared minus 2. 2 squared is 4. 3 times 4 is 12. 12 minus 2 gives me 10. And if you notice, that made a really big jump. And it's all because of that exponent there. Just like in the last example, we could then create some coordinates. We would have here 0, negative 2, 1, 1, and 2, 10. And then we can do a little bit of graphing. Let me scooch this over here. Keep my, let's keep my coordinates in view. Gonna have to make a really small graph because of how much room we have. But start off at 0, negative 2, so I don't go over left or right at all, but I do go down 2 to 0, negative 2 there. Then I have 1, 1, so I'll go over 1 and up 1 to be right there. And then I have 2, 10, so I'll go over 2 and up to 10. 6, 7, 8, 9, 10, all the way up there. That got big quick. And this does not look like a straight line as the last example did, and that's because this is a quadratic equation, or a quadratic function, because of our x squared term. But we can still graph it, and if we were to graph more of it, we would end up with a parabola, something that looks kind of like that instead of a straight line. But we don't need to worry about that just yet. So, we've talked about functions. Every function has its rule, and every function has an input and an output, where whatever you put in, it follows the rule, and the answer that you get is our output. And we can take those input and outputs to create coordinates that will fit on our graph. Hope this video has been useful in introducing you to functions. Good luck.